Hi guys, today we're going to look at magic squares, and we're going to start off by looking at a definition. So a magic square is an n by n grid of integers. It consists of the integers 1 up to n squared, i.e. all integers in the set 1, 2, 3 up to n squared. Each integer in the set 1, 2, 3 up to n squared appears once and only once inside the magic square. The sum of the integers in any column, row or diagonal is the same. We can call it S. Example 1, the classic 3 by 3 magic square. Here we have the digits 1 up to 9 and they all appear once and only once. The rows 2, 7, 6, 9, 5, 1, 4, 3, 8 all add up to 15. The columns 2, 9, 4, 7, 5, 3, 6, 1, 8, they also add up to 15. 2, 5, 8 and 4, 5, 6 for our two diagonals also add up to 15. So this is a 3 by 3 magic square. It meets all the conditions of the definitions that we stated above. So that consisted of the numbers 1 to 9, and each number appeared once and only once. Every row, column and diagonal added up to 15. So for a 3 by 3 magic square, S equals 15. To compute S is a little technical, but it can be found using some algebra. S depends on the size of the square, i.e. n. Let n denote the length of a row, column and diagonal. For a 3 by 3 magic square, n equals 3. The sum of all the digits for any magic square is given by 1 plus 2 plus 3 plus 4 all the way up to n squared. So for the case of a 3 by 3, it's 1 plus 2 plus 3 all the way up to 9, which is 45. But we've got 3 rows and 3 columns. The sum of the 3 rows is equal to the sum of the 3 columns, which is 45. So therefore the sum of any row or column is 45 over 3, and that equals 15. And consequently, the sum of the diagonals will also be 15. To compute S for a general n by n magic square, we can use some well-known facts from number theory. Now we're not going to prove these in this video, but I might prove them in other videos. So the sum of the digits of an n by n magic square is given by 1 plus 2 plus 3 all the way up to n squared. And recall that the sum from 1 to n of a sequence of integers, i.e. an arithmetic progression, with first term 1, last term n and common difference 1, that's given by 1 plus 2 plus dot dot plus n minus 1 plus n, where n minus 1 is the second last term, n is the last term, and that's equal to a half of n on n plus 1, and that's a well-known result in mathematics, and we won't prove it in this video. So therefore the sum of the sequence 1 plus 2 plus 3 up to n squared is equal to a half times n squared times n squared plus 1, where we have just replaced n in the previous slide by n squared. And since we have n rows and columns, we divide by n. And that gives us the sum for each row, column and diagonal. So therefore S is equal to a half times n squared plus 1, all divided by n. So S is equal to a half times n squared plus 1. And that's our formula for S. And we can check for the case n equals 3 So s is equal to a half times n squared plus 1, which is a half times 3 squared plus 1, when n is equal to 3, which is a half times 3 times 10, which is 15, which we found earlier. So I hope you enjoyed the video, guys, and I may look at other magic squares in other videos, like the 4x4 or the 5x5. So thanks for watching today, and please subscribe to my channel.